this video, we'll review the fundamental theorem of calculus part 1, also part 2, and introduce new notation. This is the 5.4 pre-class video. Alright, so what the fundamental theorem of calculus part 1 said is that if our function f is continuous, then the definite integral of f of t dt from a lower limit of a to the upper limit of x, that is an antiderivative of f. In other words, the area under the function f from a to the variable x defines a function, and the function that it is the antiderivative of f. Alright, the fundamental theorem of calculus part 2. What that said was if f is continuous, then the definite integral of f of t dt from a to b is equal to our antiderivative evaluated at b minus our antiderivative evaluated at a. In other words, the area under the function f from a to b, we can find that by just taking our antiderivative, evaluating it at b and a, and subtracting the two. So that's a little bit of review from the last section, but let's introduce some new notation now. If we have the integral sign, and then f of x dx, that means the general antiderivative of f. So before, that was called the definite integral, where you have a lower limit and an upper limit, but when you have no lower limit and upper limit, that's called an indefinite integral, and the meaning of it is we're finding the general antiderivative of f. Alright, let's look at some examples of indefinite integrals. So if we want to take the indefinite integral of a power function, right, x to the n, where n is some number, well, that would be x raised to the n plus 1 divided by n plus 1 plus our arbitrary constant, only if n is not equal to negative 1. So for example, if you take the indefinite integral of x squared, well, this rule says it would be x cubed divided by 3 plus an arbitrary constant. All this rule is the reverse of power rule, right? You could double check and take the derivative of our antiderivative and make sure you get back to our original function x raised to the n. Now when n does equal negative 1, we would have the indefinite integral of 1 over x, right? Because x raised to the negative 1 is 1 over x. And this ends up being the natural log of the absolute value of x plus an arbitrary constant. So all we're saying with the indefinite integral is, what's the antiderivative of 1 divided by x? Alright, next, the indefinite integral of e to the x. Well, it's saying, what's the general antiderivative of e to the x? Well, that would be e to the x plus arbitrary constant. Now that's the special case of an exponential function when the base is equal to e, but what if the base is not equal to e? What if it's an arbitrary base b? So the indefinite integral of b raised to the x would be b raised to the x divided by natural log of b plus our arbitrary constant. The next 6 indefinite integrals should be familiar to you. There are integrals of our trig functions. They are our general antiderivatives of our trig functions. And here's 2 more, where the resulting antiderivatives are our inverse trig functions. Also, the indefinite integral of a constant times a function. Well, we can just pull that constant out and say that's equal to the constant times the integral of f of x. For example, if we're taking the integral of 5x squared, that's equivalent to 5 times the integral of x squared. And then lastly, if we're taking the indefinite integral of a sum, we can split that into 2 different integrals and add them up. These last 2 rules could be derived from the definition of integrals in terms of sums, because you can pull out a constant out of a sum, and then you can split a sum of a sum into multiple sums. Alright, but the main point is that when we're taking the indefinite integral of a function, that just means find the general antiderivative of that function. Well, that's it for this video. Hopefully, you're warmed up for the next class.